We're now going to look at parabolas whose vertex is not at the origin. Let's call the vertex h comma k. All we're going to do is shift the entire parabola h units left or right, and then k units up or down. Let's look at the four forms of a parabola. Suppose that we have a parabola whose axis of symmetry is parallel to the x-axis and opens to the right. The equation of the parabola would be y minus k squared equals 4a times x minus h. We can see in that form that what we've done is we've taken h and subtracted it from x. That causes me to shift h units to the right. Then I take k and subtract that from the y value. That would cause me to shift up k units if k is going to be positive, and then down k units if k is negative. The vertex is h comma k, the focus is h plus a comma k, and the directrix is x equals negative a plus h. And there we have the graph. I do not recommend that you try memorizing this stuff. Rather, understand the shifting process. If we have a parabola with the axis of symmetry parallel to the x-axis, the parabola opens to the left, then the equation is of the form y minus k quantity squared equals negative 4a times x minus h. This is a parabola that opens to the left that is shifted h units horizontally and k units vertically. The vertex is at h comma k with the focus a units to the left of the vertex. Here the parabola opens up, again shifting h units horizontally, k units vertically. The last one is an equation of the form x minus h quantity squared equals negative 4a times y minus k. Here the parabola opens downward. Suppose that we're given information regarding a parabola. We're told that its vertex is at the point negative 2 comma 3 and its focus is at 0 comma 3. To get an understanding of what this information is telling us, I think it's a good idea to draw a rough sketch right off the bat as to what we have. So I'm going to label the vertex at negative 2 comma 3. It's right around here. And then the focus is at 0 comma 3 right here. So notice that the focus lies to the right of the vertex. That would be an indication that the form of the equation is going to open, or the parabola is going to open to the right. When the parabola opens to the right, as we have here, the form of the parabola in terms of its equation is y minus k squared equals 4a times x minus h. So we right off the bat know that k is the y-coordinate of the vertex, 3, so we have y minus 3 squared equals 4a times x minus h. That's x minus a negative 2, or x plus 2. Now all we need to do is figure out what the value of a is. Well, by definition, a is nothing more than the distance from the vertex to the focus. From the point negative 2 comma 3 to the point 0 comma 3 is 2 units. Therefore, the value of a is 2, and we get y minus 3 squared equals 4 times 2, or 8, times x plus 2. So now we have the equation of the vertex. All that remains is that we graph it. To graph it, what we need to do now is find the points that represent the lattice rectum. To do that, we locate the points above and below the focus. The x-coordinate of the focus is 0, so we let x equal 0 in this equation. We get y minus 3 squared equals 8 times 0 plus 2. 0 plus 2 is 2. 8 times 2 is 16. So I have y minus 3 quantity squared equals 16, which means y minus 3 is going to equal plus or minus 4. So y equals 4 plus 3, or 7, or y equals negative 4 plus 3, or negative 1. So the points that make up the lattice rectum are 0, 7, and 0, negative 1. I'm going to use those points to help me graph the equation. So here we go. We have that the vertex is at negative 2, 3. So there's your vertex. We have that the focus is at 0, 3. So that's on the positive y-axis. There's your focus. We have that the lattice rectum are at 0, 7 and at 0, negative 1. Finally, we have to figure out what the directrix is. Well, the directrix is going to be a vertical line, and it's going to be a vertical line that's 2 units to the left of the vertex. What is that vertical line have as an equation? Well, the equation is going to be x equals negative 4. Finally, I'm going to use the vertex along with the 2 points that comprise the lattice rectum to draw in my graph. So here we go, right there, and right there, and we have a nice graph.